Okay, great. Well, thank you very much, everyone that stayed here for staying this long. It's been a very long but productive day, I think, overall. So as you know, I'm leading the applied AI in electric engineering and computer science initiative here at the college level. So what I wanted to talk today about was a little bit about physical AI for robotics specifically, and basically what it means, and then kind of get your perspectives about that. So I'm going to ask you for a couple of survey questions with a QR code, so just get your cell phones ready once we get to that as well too. But I wanted to start basically with what's physical AI, and at a very high level, just think of physical AI as AI models that are embedding some sort of physical properties, and these are things that are going to be useful to be able to be applied to some physical system, of course. We're talking about robotics, as in the case of this symposium, but we can be talking about autonomous vehicles or some sort of smart spaces, smart buildings, so on and so forth. So it may go a little bit more into cyber physical systems, civil engineering, things of that sort. Factories as well too, like industrial engineering, so on and so forth, right? So it's not just robotics, but any type of automation that we can incorporate into this. Then the physics-based simulations, of course, these are the main core things that kind of power all these developments. And it allows us to provide basically some way of having a safe, control environment where we can do training, design, optimization, and of course, validation of different systems within the simulation first, before or while we're doing some sort of testing in the real world, right? So physical AI, in this sense, models basically aim to learn these physical laws and then, of course, respect them as well, too, as they're trying to do some sort of this inference. So what I'm going to do is I'm going to show you a couple of videos just to kind of illustrate a little bit what this is about. Let me see if it plays automatically. Nope. I think I'm just going to press play, and I guess it's taking me out of the page. Sorry. Can we switch the views? And it went to a different page, I think. It went to the browser page. Oh, wait, I figured it out. Yeah, there you go. Just a quick video.
The era of robotics has arrived. One day, everything that moves will be autonomous. Researchers and companies around the world are developing robots powered by physical AI. Physical AIs are models that can understand instructions and autonomously perform complex tasks in the real world. Multimodal LLMs are breakthroughs that enable robots to learn, perceive, and understand the world around them, and plan how they'll act. And from human demonstrations, robots can now learn the skills required to interact with the world using gross and fine motor skills.
I think the computer died. Oh, okay. Yes, it died. Sorry about that. I killed the computer. Okay, well, we're going through technical difficulties. Let me show you or discuss very briefly basically what I'm going to ask you to do later after that. This is going to finish up the video in a second, and so there it is. Okay. And I wanted to talk to you a little bit about basically
where physical AIs can be created. Omniverse is a development platform for virtual world simulation, combining real-time, physically based rendering, physics simulation, and generative AI technologies. Just as LLMs need RLHF, or reinforcement learning from human feedback, to learn particular skills, generative physical AI can learn skills using reinforcement learning from physics feedback in a simulated world. These simulation environments are where robots learn to make decisions by performing actions in a virtual world that obeys the laws of physics. In these robot gyms, a robot can learn to perform complex and dynamic tasks safely and quickly, refining their skills through millions of acts of trial and error. We built and
Okay, great. So if I'm doing this right, okay. First quick survey that I wanted you to answer, and this is a very high level, mostly just to get you familiar with my quick surveys that I'm going to do. It's just asking you about some of this awareness that you may have about some of these tools already. So you can quickly answer that. I'll tell you more or less what trends we're seeing, I guess, in here. But as you can imagine, this first part of the presentation is mostly about robotics, right? And kind of the type of tools that you would expect to see maybe in terms of simulations and so on and so forth. And then we're going to go a little bit more specialized and then talk about like what else we can do in terms of resources and tools that we can make available for education and research, besides the test bed discussions that we already had just a second ago. OK, so while I'm getting responses, I'll wait until there's at least 12 responses so I can show you what it looks like. I think there's more than 12 people in here, so OK, perfect. OK, so one of the first questions is, were you aware of the physical AI models? And about, I would say, 60% of the people are saying yes, 20% no, and then the rest somewhat. Were you aware of the value of digital twins on physical AI? And about 65% is saying yes, about 20% saying no, and then the rest basically somewhat. So there's still a significant number of people that were not really aware of those things. And then, are there any particular physical AI tools that you would like to learn more about? And we're kind of trying to summarize really quickly doing AI. So, of course, we've been talking about NVIDIA tools, too. NVIDIA is not a sponsor, just so you know. But there's a lot of tools, of course, that are available. Plus, they make really cool videos. So, very cool media to expose and present as well, too. There's responses or requests in terms of specific AI concepts and applications that could be presented as well too, neuromorphic computing and things like that are very essential now in robotics as well too, which is things that I think that we should start making our students and also our faculty aware of. And then more generally about general AI tools that could be useful for these type of things, right? So okay, great. So that was our first type of activity. Now what I wanted to talk about is a little bit more going in depth in terms of how we're using physical AI and the type of tools that we have available for this. Specifically, I wanted to talk about, briefly, surrogate models and more foundational models that are becoming available. And as you can imagine, data generation is a big piece, basically, in terms of how we're going to be using a lot of these digital twins and how we start training, basically, our AI models, right? Because we need to capture interactions with the physical world. So just having images, just having short videos is not all just enough. You need to actually have, basically, some prompting of the physical world. Physical prompting of the physical world. So that's why basically we have this data that's being generated from digital twins and simulation environments as well too, right? So of course we have standard simulations as we have in here. Simulations are becoming a lot better. We're getting things that are much more photorealistic, following more of the physics and more complex physics. We have these surrogate models that are essentially trying to capture nonlinear dynamics and complex type of behaviors. For instance, we have physics-informed neural networks that are helping us with all these type of things. And also we have these world foundational models that we're creating nowadays where we have basically these generative models that respect physical relationships because we're incorporating that as part of the training as well and allow us for basically closing the loop and have something that's closer to the real world. So it's bridging that gap that is often referred to as the simulation to real gap as well too. So I wanted to show you a quick video again on this. So let's see how this works. Okay, it opened, same page. And this video actually doesn't talk too much. It doesn't say anything. It's just a cool video that NVIDIA prepared. But pay a little bit of attention in terms of what is it that is being simulated in here, because it's not just robotics that you're actually getting, like what you would standardly think about in terms of rigid bodies kind of interacting with each other. But there's a lot of things that actually are deformable, things that are actually fluid dynamics, things that are very complex in terms of simulations, even chemistry processes, physical properties like heat diffusions and so on and so forth that you're seeing as part of that, right? Okay, and as Aranya was saying, last frontier is space, right? So, okay, great. So I hope you get an idea, basically, from this that with physical AI, you're not just looking, again, to these physical, standard, rigid body type of interactions. We're talking about soft interactions, but there's also this other stuff that is incorporated into that as well, too, in terms of chemistry, like fluid dynamics, and so on and so forth, that can be incorporated into this. So another quick survey just to keep you on your toes. Let's see what you're getting here. So this is more about awareness of some of these world foundational models that are being developed right now. A couple more responses, and we're going to switch to brief overview of responses so far. Somebody actually gave their name as S, whoever S is. Thank you. Okay, great. We have around 20 people responding so far. Great. So our first question was, were you aware of the number of simulations or the role of simulations of physical AI? And about 60% said yes. Again, around 10% said no, and the rest was somewhat. Were you aware of the role of world foundational models? And basically 55% said no, 25% said somewhat, and then 20% yes, right? So there was a lot less awareness on that aspect of it. Mention any applications that come to mind for physical AI beyond standard robotics. Engineering and materials, of course, that has been a big area that we've been talking about. Vehicular and traffic systems, of course, any type of a smart system, as I mentioned. Aerospace, and so on and so forth as well. So those are other applications that I have in mind as well. So great. Well, thank you very much, everyone, for those responses. And the last thing that I wanted to discuss is a little bit more about resources and training. And we already talked about courses as well, too, but so it'll be a little bit more on the focus on the physical AI portion of it, emphasis on the AI portion of that as well, too. So what is it that we need beyond basically standard robotics capability based on what I'm observing? And I'm going to open up the survey after this, and then I'm going to see if anybody has anything that they want to share with everyone as well, too. So we're talking about the specific workstations and servers capable of these high-fidelity type of simulations. And sometimes it goes a little bit beyond the standard kind of like GPUs for AI. So we may need like the right type of hardware to make sure that we invest on those things as well, of course. The appropriate simulation software, and as I think it was mentioned earlier as well, too, people do this in different platforms. So if we can try to standardize that a little bit, that'll be fantastic, right? It'll make things easier for people to plug in and kind of interact and collaborate as well, too. We also, as we're thinking about the deployment, we need more onboard computing capabilities for real-time inference on the robotic systems and of all these models, of course. For example, the NVIDIA Jetson platform and the family as well, too. Different type of trainings, of course, and we mentioned all these courses that we have in terms of robotics. There's a couple courses that some of them are collaborations with other folks in here, too. For instance, we have this physical accurate world scale simulation that we've been teaching with John Paul Orr and Fred Livingston, so a collaboration with in the ISE and CSC and ECE, where we're trying to basically start getting the students kind of engaged and excited about some of this physical AI portion of it. We've been kind of struggling to get the right hardware for those things, and then the platforms, of course, keep on evolving, so it makes it hard to kind of keep up with this, but the idea is to build basically a community so students don't feel alone, and they have some of these resources to ask questions and get some of their answers as well, too. So this is more on the robotic side of things. The other portion of it is physical modeling with neural networks. That's where I've been teaching more on the physics portion of it and how do we do things like these surrogate models and how do we build basically integrate physics-informed neural network architectures into that as well too, which of course translate directly into some of the robotic applications. But what I want you to think more about on the next section, and again, I'm going to open up the survey, but you're welcome to also just kind of raise your hand if you have something that you want to say, is what type of resources do we really need to be able to do this, make this happen, to take advantage of all these tools? And I guess we're talking about physical or cyber infrastructure or resources that we may need, but also things like additional trainings. So I want you to think about like what is stopping you or preventing you from using these tools now, right? And again, it could be like lack of awareness, right? Things of that sort as well too. So while people are responding, I'll see if anybody wants to share with the group. Otherwise, I'll start going through some of the responses people that are putting online as a brief summary. This is more of an open-ended question, of course. Yeah, you have a question on the back?
It's not a question. You
Comment.
said say anything.
Anything, yes.
Now I'm going to recite all the different varieties of Star Trek. No, I'm not. Just kidding. It actually goes to a previous point as well in terms of the operational stuff. So, and partly out of recent experience, it depends on who's being served and how large the service model is. And very early in that pathway, I think one requires full-time and professional operational service staff. And I look at, not in terms of robotics, that's not obviously more income to that field, but in the fields that I've been in over the years and decades, the places that have really made huge impact have had decades-long groups. And different ones are funded in different ways, but there are large, sizable groups of, continuing, overlapping, professionally hired skills and intersecting with cutting-edge technology, how to say, staying up with technology kind of things. And that's something that would be very interesting. Despite whatever we think, I think that just having smart people isn't enough. Hundreds of smart people with a fraction of their daily thinking can't really make up for full-time service.
Yes, thank you. That's a very good point. So we definitely need staff support. So yes. Let's see if anybody else wants to share any other thoughts or comments. Yeah, please, here in the front. It's coming.
Yeah, so I would say learning how to do these physical models or how to do the physical AI for areas that do not yet have their multi-scale physics embedded in these tools, right? So we have a lot of domain experts here in certain aspects of chemistry, materials, and other areas whose physics and chemistry is not captured by fluid dynamics, mechanics, right? There's some aspects of quantum that have to come in and anybody interaction. So I feel like that's probably a frontier area that this is going into, but helping the folks here understand how to do it would be very potentially impactful. And I think a lot of people would love to see these tools kind of go down to the nanoscale.
Yeah, and maybe related to that, I think there's a barrier to pass, right, between having basically the materials ready to submit to a proposal, basically, where there's already some understanding of the tools, maybe some preliminary development, awareness, and choice of what you're going to do for all of these, right, before you go to an NSF proposal or something like that. And the question is like, how do we overcome that little barrier? Maybe it's a big barrier, I don't know, at the very beginning, right? So is that a matter of just getting everyone together, like in this symposium, and people just talking to each other? Or do we need something else, like some sort of seed funding, like even a small seed funding, to try to get people talking, right, and then kind of moving them on? Or do we need to get the students talking to each other, right, so they actually do a little bit of like a small prototype project or something like that, right, and then that sparks basically a bigger proposal. So if anybody has suggestions about how that could be, that would be great. I know you have a question, but see if anybody has any response on that. But if not, we'll just go to your question.
Yeah. So there's a real tension between all the physical robots that we've been seeing throughout the day and the very cool graphics department efforts that have been made by NVIDIA to make that amazing video. I think that tension is in the sim-to-real transfer. But what's your take on that? a lot of this is open research problems still. If we train a bunch of students to, imagine that their robotics is complete because they've simulated it and then they go to implement it. You can narrow the sensorial gap. I'm not sure you can eliminate it.
Right.
What are your thoughts?
No, I think that's a very good point. And what happens, what I have seen a lot is that these kind of surrogate models end up being kind of personalized or customized to a particular type of use cases. So the general frameworks may be good enough to kind of emulate something that's physically accurate, but you still need some data to make it that physically accurate, right? Otherwise, you would need to end up doing kind of adding perturbations, random perturbations, parameter spaces, assume behavior models for physical systems or some other things. And that becomes such a huge space, right, that people still have problems kind of translating that to something that is actually properly functional. So what happens is that you still need to have some of the data, and then you custom your model to fit your particular scenario, and then you have something that is a good digital twin, and then you can use it for those use cases in there. At least that's what I have seen mostly. And yeah, very good question. I think we're out of time, so.
We could probably keep going, but it's 3 o'clock now, so perhaps we can wrap this up and continue the conversation, right? This is not the last time we're meeting. Hopefully this is the first of many, many times we're going to be meeting together as a group. So let's thank Edgar. All right, so I think we are at the end of our program, and personally speaking, I've learned so much today about, I thought that I was already very surprised at how much is going on in robotics across the campus, but being here today, I'm even more surprised in a very positive way. This event of this size could not have been possible without some key people supporting it. So the first person I'd like to thank is Patricia Poland. And then I also would like to thank Jack. I don't see him here. Jack is outside, and the team behind the logistics and the registration. And then I'd like to thank the communications team for taking pictures and helping us with branding. So thank you, Tolori, I guess you're representing. And also the IT team here at the Hunt Library, thank you to you as well. And then also to the steering committee. For being here, for meeting so continuously at a short notice for the last, feels like 1 year, but it's only been 6 weeks, I think. But because without you, this could not have happened. So thank you to the steering committee. And we have a lot of work ahead of us to do. But this has been really fantastic. And I'd like to close the symposium unless somebody has anything they want to add. Okay, so thanks again for being here. Let's close this inaugural symposium, and this will continue on. Thank you.